Welcome to the lecture series on time value of money, concepts and calculations. The present lecture is devoted to continuous compounding. In last few lectures, we have discussed simple and compound interest, and in these lectures considered the form of interest in which periodic payments are charged at discrete intervals of time, with discrete amount of interest accumulating at the end of each interest period. In practice, the basic time interval for interest accumulation is usually taken as 1 year. However, shorter periods like 6 months, 1 month, 1 day, 1 hour or 1 second can also be used. In the extreme case, when the time interval approaches to 0, so that the interest is compounded continuously, is called continuous compounding. Continuous compounding is useful because it gives straightforward way to compare interest rates between different types of compounding. Second, it illustrates that compounding more often does not really give you as much of a boost as you might imagine. And third, sometimes it really is useful to invest money for very short amount of time. Now, development of equation for continuous compounding. The basic equation which we know that S is equal to P 1 plus R divided by M to the power m n, which was used for discrete compounding, represents the basic equation for which continuous interest relationships can be derived. The symbol R represents the nominal interest rate with m interest period per year. If the interest is compounded continuously, m approaches infinite, and the above equation can be rewritten as S is equal to P limit m tends to infinite in bracket 1 plus R by m whole to the power m n is equal to P limit m tends to 0 in the brackets 1 plus R by m whole to the power m by R into R into n. The fundamental definition for the base of the natural system of logarithm, that is E is equal to 2.71828, is limit m tends to infinite 1 plus R by m to the power m by R is equal to E. Thus, with continuous interest compounding at nominal interest rate of R, the amount S n for initial principal P 0 compounded for n years is equal to S equal to P e to the power R n. The term e to the power R n is known as the continuous single payment compound amount factor. Now, let us see that what type of problems can be created for this continuous compound interest. The equation is S is equal to P e to the power R n. The above equation, which contains 4 variables, that is S, P, R and n, can be solved to find out the value of a single unknown variable only when other 3 variables are known. Thus, 4 types of problems can be generated out of this equation. The problem matrix of the above equation is shown below. Now, if P, R and n are given, we can find out the value of S, where S is equal to P into e to the power R n. In this case, we have to find out the value of S, that is future value, when present value P, interest rate R and number of compounding years N are known. This type of problem will be called problem type A. The second type of problem will be given S, R and N, we have to calculate the value of P. So, the formula which will be used for this purpose is P is equal to S divided by e to the power R n. Find the present value P provided S, R and N are known. Such type of problem will be called problem type P. The third type problem, S, N and P will be given and R has to be found out. For this problem, R is equal to 1 by N ln S by P. Find the interest rate R where S, P and N are known. Such type of problem is called problem type C. The fourth and the last type of problem is S, P and R are given, N has to be found out, where N is equal to ln S by P whole divided by R. In this case, number of periods N has to be found out when S, P and R are known. This type of problem will be called problem type D. Let us start with different problems and its solution. Now, problem number A or the problem type A. Example 1, if the nominal interest rate is 8%, how much is rupees 10,000 worth in 15 years in a continuous compounded account? There are 4 answers. The solution is P is given as 10,000, nominal interest rate is given as 8% and N is given as 15 years. So, S has to be found out. S is P into e to the power R n. So, is equal to 10,000 into e to the power 0.08 into 15. This comes out to be 10,000 into 3.32011169, comes out to be rupees 33,201.17. That means, if we invest 10,000 with a nominal interest rate of 8% for 15 years, it will provide you rupees 33,201.17 if the compounding is continuous. Again problem type A, example 2, consider nominal annual interest rate of 15% per year. Determine the total amount which will be accumulated after 5 years for an initial investment of 1,000 if continuous compounding is employed. Solution: we know what is the value of P, that is 1,000. We know the value of interest rate, which is nominal interest rate, it is 15%. We know the value of N, which is 5 years. So, we have to find out S or FB, and FB is equal to P into e to the power R n is equal to 1,000 into e to the power 0.15, the value of R, into 5, which is the value of N, and this gives us rupees 2,117. That is, if 1,000 rupees invested today for 5 years with a nominal annual interest rate of 15% and the compounding is continuous, it will convert into rupees 2,117. Problem type B, example 3. Considering nominal annual interest rate of 16% per year and the total amount which will be accumulated after 6 years as 20,896.6. For this, find initial investment if continuous compounding is employed. Solution: S is given or FV is given as 20,896.6, R is given as 16%, N is 6. So, S equal to P into e to the power R n, or P is equal to S divided e to the power R n. So, this is equal to 20896.6 into 0.3828929, and this value 0.3828929 is equal to 1 by e to the power R n. So, the multiplication gives rupees 8001.16. That means, if I invest 8001.16 for 6 years with a nominal annual interest rate of 16%, it will give me 20,896.6 rupees. Now, problem C. This is given in example 4. Find the nominal annual interest rate per year if the total amount accumulated after 10 years as 54,446.83. For this, we find the initial investment of rupees 9,000 if continuous compounding is employed. So, if we analyze this problem, we find that S is given 54,446.83, P is given as rupees 9,000, N is given as 10 years, but what is the value of R? The value of R is not there. So, we have to find it out. So, again we use the same equation, S is equal to P into e to the power R n, or P is equal to S divided by e to the power R n, or we can write down S by P is equal to e to the power R n, and if we take log both the sides, it becomes ln S by P is equal to R n, or R is equal to 1 by n into ln S by P. If we substitute the values of n, S and P into this, so this is equal to 0.1 into ln 6.049647, and this is equal to 0.1749, and that is approximately 18%. That means 9,000 will be converted into 54,446.83 rupees in 10 years if nominal interest rate R is equal to 18%. Now, problem type D, example 5. Considering the nominal annual interest rate per year to be 15%, and if the total amount accumulated after a given number of years is rupees 19,676.8, for find initial investment of 8,000, find the number of years if continuous compounding is employed. Solution: given S is equal to rupees 19676.8, P is 8,000, R is equal to 15%, and what is the value of n? So, again we use the same equation, S is equal to P into e to the power R n, or P is equal to S by e to the power R n, or we can write down e to the power R n is equal to S by P. If we take log both the sides, ln S by P is equal to R n, or n is equal to 1 by R into ln S by P. This is equal to 6.6666 into ln 2.4596, and we multiply this two, it comes out to be 5.99999, which is equivalent to 6 years. That means, the rupees 8,000 invested with nominal interest rate of 15% will convert into rupees 19,676.8 in 6 years if continuous compounding is employed. Now, again problem D, this is example 6. Find out time period in years required to double an investment using continuous compounding if nominal interest rate is 10% per year. Solution: here S by P is equal to 2, and we know that for continuous compounding S is equal to P e to the power R n, or S by P is e to the power R n, or e to the power R n is equal to 2, or e to the power 0.1 n when we put the value of R as 0.1 because it is 10%, then it becomes e to the power 0.1 n is equal to 2, and if we take log of both the sides, then n is equal to ln 2 divided by 0.1, or n is equal to 0.693147, which is the natural logarithmic value of 2 divided by 0.1 is equal to 6.93 years. So, a value will double in 6.93 years if nominal interest rate is 10% and continuous compounding is used. Let us take a mixed problem. For this, we consider example 7. For the case of nominal annual interest rate of 20% per year, determine the total amount to which rupees 1 of initial principal would accumulate after 1 year with continuous compounding and the effective annual interest rate. What are the things which are given? P is equal to rupees 1, R is equal to 20%, N is equal to 1, and S is what? That means, we have to find out S when the value of P, R and N are known. So, again we use the formula for continuous compounding. S is equal to P into e to the power R n, or S equal to 1 e to the power 0.2 into 1, because R is 0.2 and N is equal to 1. So, S is equal to rupees 1.2214. Now, I effective is equal to e to the power R minus 1, and this comes out to be 0.2214. That means, if I invest rupees 1, I can get rupees 1.2214 in 1 year if nominal interest rate is 20% and continuous compounding is used. And that is why the I effective is 22.14%, and in fraction it is 0.2214. Now, problem type D, example 8. How long will it take rupees 5,000 to triple if it is invested at 6% compounded continuously? We have 4 options, and let us take the solution. What are given? P is equal to rupees 5,000, S is equal to rupees 15,000, because it is going to triple 5,000 into 3, 15,000. R is 6%, and what is the value of N? So, we use again the formula for continuous compounding. S is equal to P e to the power R n, or e to the power R n equal to S by P is equal to 3, taking log both sides. R n is equal to log 3 is equal to 1.09861229. So, 0.06, which is the value of R, into N is equal to 1.09861229. So, N is equal to 18.31. So, your answer D is correct. So, it tells that a 5,000 rupees input can be tripled to 15,000 rupees if nominal interest rate is 6% in 18.31 years if continuously compounded. Now, again a mixed problem, example 9. The difference between simple and compound interest compounded continuously on a certain sum of money for 2 years at 8% per annum is rupees 135.1. Find the amount of the money invested. Let the sum of money is x. So, continuous compound interest for 2 years will be x into e to the power r n minus x, which comes out to be 0.17351087 x. Now, simple interest for 2 years is x into 0.08 into 2, which is 0.16 x. So, continuous interest, compounding interest minus simple interest is equal to 0.1735101 x minus 0.16 x, and this is equal to 0.01 35101 x is equal to 135.1. So, x is equal to 9999.93. Now, again problem type mixed. Example 10. The difference between compound interest and simple interest on an amount of rupees 20,000 for 2 years is rupees 270.22. What is the rate of interest per annum? Given that P is equal to rupees 20,000, N is equal to 2, and what is the value of R? So, we have to find out R when P and N are given. Let the rate of interest per annum is R. So, continuous compound interest CCI for 2 years is 2000 into e to the power R n minus 2000, which comes out to be 20,000 in brackets e to the power R n minus 1. Simple interest SI for 2 years is 20,000 into I into 2. So, it is 20,000 to I. So, CCI minus SI, that is continuous compound interest minus simple interest, is equal to 20,000 in brackets e to the power R n minus 1 into 20,000 into 2 into I is equal to 270.22. Now, by trial and error, if we put R is equal to 0.06, the left hand side becomes 149.937. If we take R is equal to 0.07, the left hand side, which is equal to 20,000 into e to the power R n minus 1 minus 2 R becomes 205.476, and if we take R is equal to 0.08, it is 270.2174. So, my right hand side is 270.22, and at the value of R becomes 0.08, it is 270.2174, and hence the correct value of R is 0.08, that is 8%. Thank you.